they've given the middle finger to OpenAI and said, hey, we don't need that really complicated way to do it. We worked out how to do it on a budget. And yeah, okay, maybe it's not going to be as good as the O3, but it's also maybe just that they haven't done it, as long as the O3 has been trained for.
Good morning, Sam. How are you?
I'm good, Matt. How you doing?
Great. Big announcement from Deepseek R1 on Monday. This model was released, this Chinese open source model, essentially kicking OpenAI's ass, right? Delivering something that's essentially on par for like 3% of the cost. I see two main breakthroughs. One is this reinforcement learning step very early in terms of training this model so that it really got this reasoning sense built into it and related to that, doing it in a really cheap and innovative way, right? The second is the kind of transparency and the fact that it's open source, right? That allows you to see how it's actually working. Would you agree that those are the two big ways that this model is disrupting OpenAI's leadership?
Yeah, totally. Especially the second one there. O1 came out sort of late last year, and OpenAI didn't tell anyone how it was done. They wouldn't sort of, they were all sort of smug about it, but they wouldn't sort of confirm how any of it was done. It was sort of like their intellectual property. They didn't want to share it. In the sort of the end of November, DeepSeek had a sort of preview light version of this R1 that they put up. What people didn't really expect, or what people didn't know was coming, was this whole paper about how they did it. And I think in many ways, it turned out to be a lot simpler than what OpenAI made out. So either OpenAI is doing it the really hard way and the really expensive way, like you pointed out, uh, or DeepSeek has sort of stumbled onto that actually to do this doesn't require as much as as originally thought. The whole sort of community is kind of blown away by the fact that this is totally open. Everyone, people are already starting talking about replicating it, talking about using it for other models, using these ideas to get things out there. They had a really nice model, actually a very popular model called DeepSeek V3. They took the exact same base model for that to use for this. Now, the DeepSeek V3 has a more sort of standardized post-training thing. And this is sort of like over the past few years, people have worked out, well, what you would normally do after the pre-training is you would do what's called SFT, or supervised fine tuning, or instruction tuning. Uh, and then you sort of finish off with some reinforcement learning at the end to make it sort of more aligned with what you want, how you want the model to act. DeepSeek to sort of throw that way of doing it out the window a bit and say, well, we're not going to do the supervised fine tuning. We're going to do this type of reinforcement learning. So they take the pre-trained model. So imagine this thing's read the internet. They give it a special prompt where they say, hey, just sort of make up a conversation between a user and assistant, and they're going to ask some sort of question, right? And you could imagine that that's like a grade school math question or something like that, like some sort of word problem. And it has a correct answer. Right? This is kind of important that it has a correct answer, because what they do is they don't use a reward model. They actually use that real answer as something. And what they do is they generate 64 examples out from this before it's done any of this other fancy training, just from the pre-trained model. They then look at those and work out, okay, what was sort of like the mean of those? What how many of them were actually getting the right answer? And then they can sort of calculate, okay, the ones that did it nicer with sort of good thinking steps, and the ones that didn't do it in that way. And then they use that to update the model. And they found that just doing that alone got them a lot of the way there, but it didn't work 100%. And the reason, one of the reasons could be is that they were doing it in English and Chinese. So the thinking would come out where some of it was in English and some of it was in Chinese. And they're like, okay, we don't want that, right? So we're going to try and, redo this. So what they did was they took the best of those examples. They took just like a few thousand examples. They went back to the start. They did sort of a bit more conventional sort of thing with the SFT, where they did the training, but only on a few thousand examples. Then they do this reinforcement thing. And it turns out that that worked really well. Then they were able to sort of just do a more sort of conventional pipeline. They've come out with this model that's like doing fantastic.
I find throwing out that SFT step at the beginning, right? The supervised fine tuning was it seems like that was key in the sense that this traditional approach has really created this. It's almost like a brittleness, right? Where you're forcing these models with kind of these rigid ways of answering certain questions and data sets, when really by throwing it out and moving straight to the reinforcement learning step, you're encouraging the model to really think through the reasoning steps itself. But and essentially, what you're saying is that while that didn't quite work perfectly, because there was these issues that it experienced, but they were able to then go back with a smaller, more focused SFT approach, right? That didn't then ruin that fundamental reasoning step at the beginning.
You had a really good point there, Matt, where you sort of said you don't want to force a style of thinking onto these things too much, but that's going to limit it in some ways. And one of the things that they kind of sort of hinted at a lot of during the paper was that by getting the R10 model, the one that only did the reinforcement learning there, by getting the best outputs from that and using it, all these outputs were compatible with this model, meaning that it's not like you're forcing someone else's thinking on the model. It's just basically applying its own thing, which is compatible with this model. And that seems to have been, something that that really helps it. All right, Matt, let me just walk you through something here that's really interesting. And hopefully this makes this a little bit clearer. If we look at this, we can see we've got four models here. We've got the Deepseek R1, the OpenAI O1. We've got a distilled Deepseek 32 billion, which is actually a version of one of the Quen models. Then we've got OpenAI's O1 Mini and then Deepseek V3. Now, Deepseek V3, remember I was saying that is the same base model that R1 is trained on. So if you look at just the stats, when you compare that Deepseek V3, even on this first one, you can see that like the lowest one, the Deepseek V3 is getting 39.2 there. But the exact same base model, when they've done this new RL way of doing it, you can see it jumps right up to 79. 0.8 for that one. And if you compare it for all the other ones, you see a pretty good jump most of the time. The other thing that this diagram shows us that's really interesting, comparing the original Deepseek 3 to this improved Deepseek R1, and comparing this Deepseek R1 to the Quen 32B one, the Deepseek R1 32B that you see there. That is, doing really well. Later on, they even go on to sort of show that that's beating O1 Mini for lots of different tasks. They start off by the contributions, talking about this whole idea of post-training. And this is sort of a key thing. They didn't do anything different pre-training, but they show that, yeah, they applied, RL directly to this base model without the SFT stuff as the preliminary step. And this is sort of the key thing. And there's a lot of interesting sort of thinking around this, is that originally chain of thought was something that they noticed that the pre-training models just did by themselves every now and then. And this is that came out of Google, and DeepMind has sort of been talking about that recently again, where we've seen for the last 6 months or year, that chain of thought has been trained into models, sort of like ingrained into models. What they've gone and done.
How is it ingrained? How is it trained into the models?
So with the supervised fine tuning, how about you scroll down? There's another diagram. One of the interesting things, Matt, that they show here is that this chain of thought, as they encourage it and sort of coax it out of the model, it gets longer and longer and longer. Right? Scroll up to the one just before. Yes, this one. Okay. And as it gets longer, we can see that at this particular benchmark, as it gets longer, it also gets more of it right For you to get good results, you have to think about it first. And sometimes with hard questions, you kind of want to meander around with your chain of thought and your thinking to arrive at that sort of sweet spot where, okay, that's the right answer. And what these both of these graphs sort of show us is that that sweet spot takes a while to get that length of chain of thought where this model becomes really good at this. In some ways, they've given the middle finger to OpenAI and said, hey, we don't need that really complicated way to do it. We worked out how to do it on a budget. And yeah, okay, maybe it's not going to be as good as the O3, but it's also maybe just that they haven't done it, as long as the O3 has been trained for. Even a lot of the large tech labs will be looking at this paper going, "Ooh, we should try that as well," right? Or, "There's some very good ideas in here." Most sort of RL, you would have a different sort of what we call a reward model, a model that basically decides that something's good or something's bad. Like, what are we trying to encourage out of this? For this R10, they adopt this rule-based reward system. Uh, and this sort of consists of these rewards, and they talk about a lot of these things being math problems with deterministic results. They're sort of word math problems. Like, the really simple ones would be something like, the school canteen had 23 apples. They sold 20 at lunchtime. They bought 6 more. How many apples do they have left? Right. And it's not that difficult for you to sort of think that through. But as they get more complicated, you've kind of got to work out, okay, well, at this point they had this many apples, and at this point it was like 23 minus 20, and then to get to the sort of the answer 9. But the key thing is there is a deterministic result there, that 9 is the right answer. So if the model doesn't say 9, you can penalize it. What they're doing is saying, right, this deterministic result, we're only going to do things when it gives us the right answer, we're going to say, oh, that was good thinking. And you notice, though, that they also have this format thing there where it has to wrap its thinking in these tags. So it's got like an open think tag and a closed think tag. And if it doesn't give its thinking, then they also penalize it. They also say, no, that wasn't good. That wasn't good.
Got it. Whereas in most cases where this approach is applied, right? This is we don't know fully, I guess, in terms of OpenAI's O1 model, but what would the approach be there? That the reinforcement learning doesn't rely on correct responses. That the responses are just good enough. Is that what you're
Okay.
saying?
The real answer is we don't know, Matt, right? Because,
Okay.
it's such a black box system. What people have guessed at is that they actually do sort of verification step by step, meaning that at different points of the chain of thought, they sort of score it. I'll tell you a really interesting story. In 2017, we were at the what was then called the NIPS conference. And, people got up and gave these really long, complicated, answers for how they thought, models were going to get better and stuff like that. In hindsight, the Transformer paper showed, no, 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 no. All you have to do is just predict the next token. In some ways, this is kind of like an interesting thing like that, where it's saying, well, we found that we could just do this deterministic way, start out with math, start out with code. They talk about like leet code problems, which are sort of like coding problems. Uh,
Right.
and they could use this to teach it to sort of think well and then expand it out over time. It's fascinating that this works so well, and is reasonably simple in how they've done it.
So Sam, so this is the area where I think the O1 model from OpenAI gets its shit handed to it, right? My understanding is that it's clearly thinking before it answers, right? But it's producing this long internal chain of thought before responding. And while it looks like R1 is doing that, what it sounds like is that R1 is actually creating a lot of efficiency in the earlier steps by having this reasoning built in before it gets to test time, right? It sounds like it's able to avoid a lot of this, this long chain of thought process, and is doing it in a much cheaper way.
The training is in a much cheaper way. The challenge is we don't know exactly what O1 does, right? We don't know what O3 does.
Right.
We know from OpenAI that they had a paper called "Let's Verify Step by Step," which is not exactly what the R1 does. R1 sort of says, let's just take the whole thing and check for right answers or wrong answers. And then what they found was that sort of training the reasoning enough on things where they did have the right answer was enough to get it to reason about things where you don't necessarily have a fixed discrete answer. The chain of thought thing is actually kind of the same for O1 as R1. The only difference is that OpenAI is not giving us any of that chain of thought. They're hiding it, right? They're not showing it to us. They've told us that oh no, you don't want to see that. We want to use that to predict if we've reached AGI and all this sort of stuff. The real reason seems pretty clear from this paper, and this is the bit about the distillation stuff that with R1, once they had 600,000 examples of this chain of thought and just sort of 200,000 normal fine tuning things, they fine tuned all these other small models, including models that are only 1.5 billion parameters, right? This is tiny. This will fit on your phone. And they were able to get it to beat, Anthropic's Claude Sonnet 3.5 at certain things. Like you said, it's a huge win for open source and for just people going, you know what? Here's what we did. Here's what worked. And even in the paper, they talk about, some of the things that didn't work and a whole bunch of things like that. And they've just added a really cool thing to it, Matt, too, is that now you can use it with search. So let's jump in and have a look at that. Okay, so if you want to try out the Deepseek R1 model yourself, you can come into their version of ChatGPT. This is at chat.deepseek.com. Totally free, won't cost you anything. And you confront it with a few different options. So if you want to just use their basic Deepseek V3, you have this DeepThink turned off. And if you want to use the Deepseek R1 model, just turn this on. Now you can turn on search as well. So we can ask it things like, tell me about the Deepseek R1 model. And so you can see that it's gone off, done searches, got 32 results. It's doing the thinking. It's going through all of that. It's looking at, you can see here, it's looking at, the different web pages that it's gone through in there. Sure enough, it's getting the results back very accurately. We wouldn't expect this necessarily to know about it itself and all the details, because obviously they were released after the model was actually made. So it's clearly getting the information from the search in here. But you can see, sure enough, we've got citations about it. It's got a whole bunch of things about how it works. We can ask it, how does it compare to OpenAI's O1 model? Again, you can see it's done a bunch of different searches in there. So here are the thinking tokens. You can see that the thinking tokens, this bit, we can sort of hide those or we can look at those. Obviously, for harder problems, it will think for longer as it's doing this. And you can see in this case, it was 11 seconds. It's talked about the different results in there. It's compared them between the OpenAI O1 and the DeepSeek, and it's basically made up a nice little comparison tables so we could check this out here. So go try it out yourself, have a play with it. Like I said, totally free, not going to cost you anything to try it out.
So the takeaways here, Sam, is basically that at every corner, kind of every approach, it looks like this company behind R1, High Flyer Capital Management, right? It's a hedge fund. But what they're essentially doing is they're kind of representing this emerging Chinese way, right? There's this now dialogue in the community around how the Chinese open source models are approaching these things. But it's basically um, simplicity, right? Focused on agility, right? And kind of really kind of clever workarounds, cost effectiveness, kind of innovative ideas. Whereas I think there's now this dialogue around how OpenAI, right, is kind of representing the American approach, right, which is like massive amounts of compute. A $500 billion fund to be able to create the compute needed to run these really expensive models. And so there's this debate now emerging about whether that really is the way and whether you can actually have an ROI from such an expensive approach.
Matt, you got to explain to me why is it though that everyone hates OpenAI and maybe even like Sam Altman so much with all this stuff? Because whenever I open Twitter, like there's a lot of people taking glee in this paper that have no knowledge about what it actually means, but they like the fact that it's sort of taking OpenAI down a peg or two.
Sam, it's a great question. Let's face it. This is a big emotional story, right? There's a ton of money on the line. Silicon Valley has long been considered a blood sport, right? Venture capitalists fighting to get into deals, and there's this whole insider um, community, here. But I think to answer your question, um, I think there's a certain amount of annoyance and kind of people getting bothered by the OpenAI's lack of transparency, right? So the constant hype, right? That we're nearing AGI, right? And it's biased because it needs to have AGIs because once it gets AGI, it can then be independent from Microsoft, right? And actually can enjoy more of the fruits of its labor. And so I think this idea, that there's conflicts in its approaches, right? That whole board fallout. I think there's a lot of people gunning for OpenAI and what it's done. And there's a lot of users such as myself. I love the product. So, but there are these mixed emotions. It's like, but why? Why spend so much money and going the expensive approach to go after AGI when some of us are more kind of maybe grounded in, hey, let's have solutions right now that are solving our problems and maybe not get carried away.
It is very fascinating, and we haven't even touched on yet that Google released a new version of their reasoning model this week on Tuesday, the day after. And had it not been for DeepSeek, that would have been the biggest news of the week, right? This is a substantial bump on the one that they released as an experimental model in December. I think it's up 40% for some of the results that they're getting, or certainly up a lot for some of those results. Playing around with it, it also seems really, impressive. And yet again, they're giving it away either for free for everyone to try out, but even when it seems like it's going to go into production, it's probably going to be way cheaper than the OpenAI ones. So
Okay,
you've got
so then what's your take there? Is that an answer to the Chinese model? So, if it's leading now in the chatbot arenas, which is considered the leading model, but on a lot of parameters, it's now free. Obviously, it won't be free later on after the test version. But is it using the same compute? Is it using the same approach as OpenAI?
yet again, we don't know, right? The Western labs are being very quiet about it, about how it's made and stuff like that. It is definitely an improvement over their first version, and they've even openly said this is not the end, right? This is just another stepping stone till we get, before we get something else.
Okay, so Stan, so here's the response that you hear from any of the US providers when you bring up these open source models. And Mark Zuckerberg brought this up on the Joe Rogan podcast. Ask it a question around Tiananmen Square, right? Ask one of these Chinese models, and you're not going to get a really good response. Now, obviously, Zuckerberg isn't necessarily referring to its own problems, right? I think it's getting sued, if I'm not mistaken, for using certain data sets as well. But can you talk a little bit about how important these things are for actual usage? Are enterprise companies going to actually use this stuff if there is this perception of biases like the one I mentioned?
I think all the models naturally going to have some bias, right? There are
Right.
some biases that that maybe we tolerate more than other biases and stuff like that. Mistral made a whole big deal that people in Europe didn't want a model that sounded like Californians, right? And that's what ChatGPT was. I the thing I kind of feel I about this personally, having spoken to a lot of devs in China and stuff like that, when you talk to the devs, this is like they can't break the law, right? The CCP is laid down. This is the law. You can't talk about this or this or this, right? So they have to put their filters in, for those things. but it's not like they personally want to do those things. It's just like that happens to be the law there. So they're complying, with that. Outside of that, most 99.999 things that people are going to use are never going to touch on those things. The thing I'm wondering, Matt, is like 6 months from now, are we going to have OpenAI say, right, we've reached AGI and here's how we prove it and stuff like that. And then 2 weeks later, someone in China says, right, here's the model that does AGI. Here it is. You can run it on your local computer. That's going to be pretty amazing if something like that happened. A lot of investors in OpenAI are not going to be happy about that happening.
Right. Well, look, I got to say, it certainly feels like that's the sort of thing that's going to happen. I think OpenAI had the story on its side, maybe early part of last year and the year before that, that maybe we were giving it credit for all the work that it had done and getting to AGI faster than others and having some sort of, year or 2 or 3 year advance. That's just no longer the case. There's no way they have any evidence to prove that. So I do think that that's probably more likely your scenario that you just outlined than otherwise. Great stuff, Sam.
Thanks, Matt.
Thanks everyone for watching. Like and subscribe for more insights into the latest in AI and tech. For deeper analysis and updates, visit VentureBeat.com.